this is the work that you needed to get done. This is how it works. These are the expectations of being in Calculus BC. Just because you're absent, that doesn't actually mean anything to me. It means you're going to watch the video. It means you're going to turn in the homework, because that's what BC students do. All right, so on the first one, f is this function. What are the x-coordinates for points of inflection? Well, I know that if f has a point of inflection, f changes its concavity, which means that f prime changes from increasing to decreasing or decreasing to increasing, but I don't see a graph of f prime, I don't see a graph of f, I have to go to the number line test with f double prime.
Is that what you're going to expect us to go here?
Hold on. The reason that I'm going to do a number line test is I don't have a graph.
Oh, wait, yeah, never mind.
I don't have a graph to look at. I don't have any of those other tools. So the number line test is going to work really well here. So I find f prime, easy peasy. I find f double prime, set that equal to 0. The numbers I'm going to use are 0 and 1. Is everybody okay? Easy peasy. Label your number line. Here's f double prime. I have a root at 0. I have a root at 1. And then we're going to test our points. I don't need to see down here that you're testing the points. I just did it so that we'd be okay. So how's everybody feeling about number line? This is a good thing? Okay. All right. Now, the signs go negative, negative, positive. Thanks, polynomial. Why? Did anybody know that the signs had to go negative, negative, positive before you plugged all the values in? You knew? You knew? Anybody else know? There's something happening here. If you think about pre-calculus knowledge, there's a reason you should know that it has to go, your number line has to go negative, negative, positive. Celeste, why?
Because you know that f double prime is a cubed function.
Okay, f double prime is cubic, so this is good. But now cubic, how do the ends go on a cubic?
They go in opposite directions.
They go in opposite directions, right? One up, one down, or one down, one up. Which one here?
One down, like that, how you are.
Like I am here, right? Because the leading coefficient is positive, one down, one up. But one down, one up, why doesn't it go like negative, negative, back to positive? There's something else here. Celeste, you're frozen for a little bit. There's something happening with the roots, right? Because the conversation we just had makes me think, oh, I should see a graph like this. And so wouldn't number line say negative, positive, negative, positive? There's something about the roots. Carmen, what's happening with the roots?
Since it's x squared, and since it's x squared, it's gonna do like kids.
It's going to do, there's a special name here.
Double root.
It's a double root. And Celeste totally does not understand nor respect being frozen. She's like, me again! Okay, so you have a double root at x equals 0, and so Mr. Link probably told you, oh, ignore that. Hopefully the kids at North Central can't see that. All right. Okay, and then it's going to go down, and then it's going to go back up. Negative, 0, positive. If you understand polynomial behavior, oh my God, you save yourself so much time. So much time gets saved. Or you plug in and your number sense skills are strong and everybody's good. So where do I have a point of inflection? F double prime changes negative to positive at x equals 1. F has a point of inflection at x equals 1. Done. Most common mistake, Myra, is going to be the kid that says point of inflection at x equals 0. David, why is that going to be a mistake? What's the mistake in saying x equals 0 as a point of inflection?
Because it's not actually changing sign.
Okay, because what?
It's not changing sign.
Because what? I'm not getting older.
Because f prime is not changing sign. Changing sign. F prime.
Okay, because f double prime is not changing sign at x equals 0, this doesn't count as point of inflection. Two good looking words. I'm sorry, what?
The function has to change.
Not the function, f double prime has to change sign. Right, I'm being so picky. So picky about this it, because f, f prime, f double prime, what are you talking about? What f are you talking about? Which is different than saying what the f are you talking about. Those are different. Just saying. Just saying. Alright, if you did those, then the rest probably went pretty well. This one I want to know where f is decreasing, so f prime is negative. Take a derivative, find the roots. Hey, these are single roots at x equals -2 and x equals +2. And it's a parabola, so I'm going positive, negative, positive. Where's f decreasing from -2 to 2? Is everybody okay? Alright, number 2. Now I actually gave you f double prime. I'm a giver. I'm a giver. Oh, such a giver. If you went and found the derivative, shameful. You already had the second derivative. So you just needed to figure out where are the roots. -1, 0, and 2. This is degree 4. Degree 4, tails both go up or tails both go down.
Yes.
Right? If you were to multiply this out, you'd get an x squared, you'd get x to the 4th. So you'd expect both tails going up.
Yes.
Positive in the beginning, positive at the end, and a little bounce over here at x equals 2. Kind of like when I'm walking around on campus, I got a little bounce. X equals 2, little bounce, focus. Alright, so f double prime. David, where are we going to have points of inflection based on our number line?
At x equals -1 and x equals 0.
At x equals -1 because there's a change, and
X equals 0.
x equals 0 but not at x equals 2 because of the bounce. Or the kiss, depending on how you've been raised. Alright, last two, I'm just going to let you take a peek. F is increasing, f prime is positive. My answer, -infinity to 0, 4 to infinity. Part B. Part B, f has a relative max at x equals 0 and a relative min at x equals 4.
You go over there.
Can I go...
The part B.
Okay. If the number line's okay. Part B, I'm asking where does f have a relative max? For f to have a relative max, f prime changes positive to negative at x equals 0. In order to be a minimum, f prime changes negative to positive. X equals 4. Uh-oh.
Why is f prime a cube root if f
A
is-
cube root?
Cube function.
Yeah, cube
Cubic?
function. Sorry. If f is to the power of 5.
Oh, no, it's not. F prime is 5x to the 4th minus 20x cubed. My 4 got eaten up by the g.
Oh.
And so then I factored out the 5x cubed. Alright, I think that's more than enough time on the homework check.
Yeah.
Okay.
I just looked in the.
So let's put that in the middle of the table, please. My paper picker up, or if you could pick up my papers, please. You try saying that 5 times fast, see what happens.
Paper picker up, please.
Paper picker upper, pick up the paper, please. Don't try that at home, kids. Alright, Stephen, we're going to the sideboard here.
No.
Write your name on it.
Okay, Stephen's apparently distracted.
Huh?
Yep.
Start recording.
He said Steven's distracted. Huh?
Recording.
I said, "Are you taking out the papers?
No.
No, I said, Stephen, I'm going to go to the sideboard. Stephen just kept, I'm not sure if he was looking at his teammates or his homework.
My homework.
Stephen's a multitasker, so you never really know what you get with Stephen.
She texted me.
Excellent. And attendance. Okay, perfect. Perfect. All right. So Stephen, I'm over here on the sideboard. Hi, good looking guy. Well done. Good looking guy in the blue. All right, today it's time to expand a little bit more. Time to expand a little bit more. Right now, you know 3 functions. There are 3 functions that we always talk about. We've got f, which is like your original. Okay. Another important function that we talk about? We talk about f prime, F prime is the derivative. And then another important one that we talk about, F double prime. Okay, the second derivative. And we've been really good. We've learned all sorts of relationships. Like if I said F has a cusp point, let's get some hands on this. F has a cusp point, what do you know about F prime? Let's get some hands on this. F has a cusp point, what do you know about F prime? I see Myra. I see Steven. Myra, F has a cusp point, what do you know? F prime does not exist. Okay. What if I said F prime? Make sure you're listening for this. F prime has a point of inflection. F prime has the point of inflection. What do you know? I see 1, I see 2, I see 3. Polymon, what do you know? If F prime has the point of inflection. But he whispered it. I'm going to pretend I didn't hear it.
No, I said we just said it.
Oh, if F prime has a point of inflection, what do we know here? I don't know. F prime has a point of inflection. F, what do we know? Okay, I'm wasting my time there. I don't like doing that. Aaron.
That F prime changes in concavity, right?
Okay. Saying F prime has a point of inflection, saying F prime changes concavity, same thing. But you also know something about F double prime. Lewis, what do you know?
Change from positive to negative or negative to positive.
I disagree. I'll say it again. F prime has the point of inflection.
Increasing to decreasing.
So F double prime changes from increasing to decreasing or decreasing to increasing. There is a function that would change from positive to negative or negative to positive. If F prime has the point of inflection, then you know what's going to change from positive to negative or negative to positive?
F triple prime.
F triple prime. You can go down this list as far as you want to. The third derivative is not something we're going to talk a lot about. But all the relationships we've talked about are about a function and its derivative, or a function and its second derivative. So for example, if I said F triple prime, let's go crazy. F triple prime has a vertical tangent line. Have a conversation with somebody near you. What do you know for sure? F triple prime has a vertical tangent line. What do you know? F triple prime has a vertical tangent line. What do you know for sure? F quadruple prime
We'll have a vertical asymptote.
will have a vertical asymptote. This guy here is your fourth derivative. Everybody's okay? This function has the vertical tangent line. The derivative of this function, F quadruple prime, has a vertical asymptote. We're good? We can go down this list as far as we want to go. We can also go up the list to go to something that we're going to call capital F. This guy here is the antiderivative. As we go down the list, these are all derivative relationships. So now we're going to look at F, little f, as the derivative of this antiderivative. There's some bigger function. There's some bigger fish out there. The antiderivative. When I take the derivative of an antiderivative, I get back to the original function. Stay with me, it's going to be okay. So for example, let's go through this list and see what we can do. Hey, good morning, Mr. Link.
Hey, Miss Fleming, save us.
No. Little f is increasing. Let's get some hands. What do you know for sure? I'll take anything. What do you know for sure? Little f is increasing. Palamone, here's your second shot for the day. F is increasing. What do you know?
F of prime is increasing and F prime is positive.
Hold on. F is increasing. What do you know? What's the it though?
F prime is
F prime is greater than 0. Does anybody know something else about some function in my list? F is increasing, F prime is positive. There's one more thing that we know for sure in this derivative chain. David?
It'll be F, capital F.
Capital F. What's the word for it?
Antiderivative.
Antiderivative, tell me about the antiderivative, David.
It's gonna be calculus.
Antiderivative has to be concave up. Nicely done. You can work this derivative chain up, you can work this derivative chain down. I will tell you, if the only thing you know is that f prime is positive, what you're saying is f prime is like above the x-axis, that won't be enough to tell me anything more. Saying f prime is positive doesn't mean f double prime is increasing, it doesn't mean f double prime is decreasing. All you're saying is, on the graph of f prime, I have a point above the x-axis, you don't have enough information. So we're just gonna cross this guy off the list. Okay, based on all that, you get 3 minutes, show me what you can do with the rest of this table.
Okay, the second one has enough. But I'm just saying.
No, there's a negative sign there.
Oh,
Oh, that's just.
Oh, I thought I marked that last.
I thought I was like a loose guy.
Yeah, I
The
know.
kids are losing
I
the
thought I accidentally did that.
test.
Yeah.
All
If
of
it's
them.
negative.
he said, yeah.
Excellent.
Good.
Excellent, wait till you see what's coming your way.
Oh, I'm already ready for the I already tried it.
And
The reason I'm watching.
maximum at x equals c.
So you also cross it out right
Oh,
here.
that means,
Just your instinct.
then that means,
The force is strong in you.
we're like,
Maximum and it's supposed to be prime changes. Negative.
yeah.
Change from negative to positive.
Changes to positive. F prime changes to positive, negative.
Why you skip all of these?
Because you skipped the last row, because you were trying to cross out all of them for all that.
Quick question.
Oh, this is a regular. No, this is, yeah, this is a
Yeah.
I didn't realize like.
Because if it starts negative and then changes to positive, then
Really?
That doesn't mean
Maximum.
no.
Is
That's the other way around.
Because it goes from negative, look, it goes from negative to positive.
I'm sorry, Aaron, what? Yeah, what?
So do all of them have vertical?
Never it. We've got now like this infinite list of functions. Never it.
Changing negative to positive. That's the point.
Yeah,
So
really.
then the one above it.
I thought this was a. Yeah.
This
If
one,
you
the
think about it,
antiderivative has a point
goes
of
like that.
that means
All of them should be going like that anyway.
Right, but look, you're talking about this, you're thinking of this one more than that. This has a point of inflection, yeah, but it's like the last
Which
one,
one?
which is relative.
okay.
Decreasing.
Plus point. F of x.
Oh,
Andrew, you're not doing all the work, right? They're not making you do all the work. We're not their calculus monkeys.
It's raining really good.
this one,
No, because I know we're like that, you can't check.
this one doesn't
Right,
matter.
you said negative one.
Meaning
Vertical tangent
it doesn't exist for the rest of
You can,
or the custom.
Yeah, everything good.
You ready?
it's a lot of
Does not exist for
All right, friends. When I lay calls your name, I want you to give me something that you know for sure about some value in this table. LA, take it away.
Aaron.
Aaron, what do you know for sure? You can take any box and any column.
capital for the antiderivative.
Which column am I in?
Second.
Second one.
Wait, is that right? Yes. Okay. Whoa. The anti-function concaves down.
The anti-function,
The
hold on.
derivative.
The antiderivative is concave down. Okay, Aaron, what else do you know since you kind of went for
I know that because of that, f of x is decreasing.
f of x has to be decreasing and
And f prime of x is negative, as you already put. And
Yep.
f double prime, there is nothing.
there is nothing, right? Basically, it mirrors all the stuff we just talked about. All right, good. LA, who's up next?
Andrew.
Andrew, give me a column.
The antiderivative
Which column are you in,
of the
Andrew?
vertical asymptote.
You're in the vertical asymptote where big F has a vertical asymptote?
Yes.
Yeah, what do you know?
of x has a vertical asymptote?
Oh my God, if F has a big F has a vertical asymptote, then little f has a vertical asymptote at x equals c. Andrew, can you take it all the way across the finish line?
Then f prime of x has a vertical asymptote by x.
F prime also has a vertical asymptote. Can you go any further, Andrew?
F double prime has a vertical asymptote.
Such an inspiration to us all. F double prime has a vertical asymptote. The way I think about this, once you catch a vertical asymptote, it's with you forever. All right, next.
If the antiderivative has a vertical tangent line.
Oh, this must be you. Okay. So if the antiderivative has a vertical tangent line,
Then f of x is.
can you guys show me vertical tangent line again? It's been a while. Vertical tangent line. The antiderivative has a vertical tangent line. What do you know?
Then f of x must have a vertical asymptote. at x
Then
equals
f of x has a vertical asymptote at x equals c, and we're just going to copy all the beautiful work that Andrew just did, because once you get a vertical asymptote, you have a vertical asymptote forever. Ile, who's next on the chopping block?
So,
Giselle.
for the first point,
For cusp point,
f of x is
if you have a cusp point, then then little f does not exist at x equals c. Anything else you can tell me, Giselle? If the antiderivative has a cusp point, then the derivative doesn't exist there, right? What about that guy's derivative?
It'd be,
Oh, wait, it also.
this would be.
If this guy doesn't exist, there's not even like a point on the graph, then you can't take a derivative and you can't take a second derivative. So does not exist all the way down. Okay. All right, Ile, who's up next?
Steven.
Steven, what you got for me?
For the antiderivative on the last column,
Last column.
it'd be point of inflection.
Well said. Now let's bring everybody else into the fold here. What you know is that f prime changes from negative to positive. If f prime changes from negative to positive, what do we know here? What's the change here? If f prime changes from negative to positive, then f makes a change. That change is going to be from decreasing to increasing at x equals c. And if little f is changing from decreasing to increasing, then what Stephen just said, you're going to have a point of inflection at x equals c. If f prime is changing from negative to positive, meaning, oop, I was below the x-axis, now I'm above, you actually don't know enough. You don't know enough to say anything here, so I would just cross it off the list. This last one, I'll take it. If f has a relative max, then f prime, easy peasy,
Change from negative to positive.
is a change from positive to negative.
Wait, yeah, I did right
And I don't know anything about f double prime. But if little f has a relative max, then big F? Well, hold on. Saying relative max means change from increasing to decreasing.
there.
So this guy up here
Point of inflection.
is a point of inflection, because a relative max means you changed increasing to decreasing, which means the function above it changed from concave up to concave down. Point of inflection. All right. Everybody mostly okay? Trailblazers, we're okay? Trailblazers, thank you for the invitation to the picnic next Friday. I'm gonna try to get there
Oh,
because
thank you for the.
Thank you.
Thank you.
I like food. No, it's just me.
Tifty.
I don't even know what that means. All right. So now let's push the skills a little bit more, shall we? Oh my gosh, I'm a pusher. Let's keep pushing. All right, so now that you guys have a bit of a grasp on f, f prime, f double prime, and the antiderivative, let's push the thinking a little bit more. In this first row, oh, it's going to be a little awkward on the page there. We'll make this work. Okay. On this first row, you have on the far left the graph of a function little f. Somewhere in this list is f prime. Somewhere in this list is f double prime. Somewhere in this list is the antiderivative, and because I'm a pusher, somewhere is a function that's got nothing to do with anything. Because in the past, what happened, all the kids were like, oh, I understand F, I can find F prime somewhere in this list. I can find F double prime somewhere in the list, and the one that was left must be the antiderivative. That's not pushing your thinking. This is pushing your thinking. So based on this being the graph of F, I want you guys to take 2 minutes at your tables here. Figure out which one's F prime and why. Which one's F double prime and why. Which one's the antiderivative and why. I want justifications. I want practice with the writing. Yes. We are practicing the writing skills.
Then F2 is the one.
So that rules out option three.
Option 2 the
Doesn't this increase?
Could you increase to -1 and then you increase again on 1?
Is option
so-
one?
I think it's 1. Oh, never mind. Nothing in use.
So option 4 is F prime of it.
And then
It does
there's
go negative.
Stop saying it. I can hear all the its.
Uh,
There's too many functions to use the word it anymore.
No, it's option 1.
Because F of X is it's decreasing.
Option
So
1.
you're gonna have that.
Oh, wait.
Because it's
Yeah, you're right. You're right.
Yeah.
F prime.
So then F would be
So this one, so
If-
F.
so then, yeah, option
So
3.
option one.
Option 3 is
Is
F.
increasing.
So have you guys found one?
Anti-prime, yeah. F.
No.
So what else?
You think that one's at prime? Tell me why.
Capital.
Give me some reason.
And then option 4 is F. Because look, option 4 would be, yes, because look, it's increasing the whole time. So then F would be positive the
There
whole time.
have
It's
to be
increasing.
things that you see about this as the graph of F that tells you where the graph
this
of
one
F
is
prime is. Give me a reason.
Anti-prime. The first one. Since this one's increasing.
Yeah. Since F is increasing,
But, yes.
Yeah, no.
F prime must be positive.
The option
Wait, so option 2
That's
Then
right.
F prime prime?
F
Yeah.
prime is negative. So I'm looking for a graph that is positive and then negative. So I hear you saying it's option 1, but what I don't see you thinking about is that option 4 has
That's what I
the
was
exact
saying.
same behavior.
Oh, I see.
So you're right to cross off 2 and 3. There's more. I need
This
the
one
more.
starts decreasing.
Let's do this. Let's do with this.
Have you guys found any that you feel like confident about?
My head hurts.
That's how you work.
No.
I'm making my own problems.
Look at the the slope.
Option 4 is
So
like
it has to be.
Maybe you got to find some stuff fully already.
Just wait. All right. All right, so let's start with the easy one. If this is the graph of F, the graph of F prime, show me in your fingers. Which one do you think the graph of F prime is? I see one, I see one, I see lots of people giving me the finger. Fine, be that way. Yes, this is the graph of F prime. I need some evidence. I want statements, full statements. Lewis, give me something.
The graph f of x changes from increasing to decreasing on x equals 1, so f prime of x
Okay, changes from
positive
increasing to decreasing where?
at x equals 0.
At x equals 0, which means F prime does something.
Changes from positive to negative at x equals 0.
Positive to negative, stop saying x equals 1. 0. Oh, you didn't say x equals 1? I'm sorry. So F changes from increasing to decreasing at x equals 0, so F prime must change from positive to negative at x equals 0. Okay, but that means it still could be 1 or 4. I did not pick these functions by accident. So I wouldn't pick 2 or 3, but it could be 1 or 4. I need something more. There's something more. You're frozen. Look at the ends. There's a clue in the ends. Myra?
At f of x, it's graph goes to 0, so it's slow.
Say that one more time. F is doing what?
F is approaching 0
F is approaching 0 as what happens?
as x
As x
gets closer to infinity.
gets closer to infinity, F gets closer to 0. I think we have a fancy word for this. X, it's getting closer to 0 as the x is approaching infinity, but there's a fancy word for this.
Horizontal.
Horizontal asymptote. F has a horizontal asymptote at y equals 0. You could say like as x approaches infinity or as x approaches negative infinity. Both things are true. If F has a horizontal asymptote, what do we know about F prime? F prime approaches 0 as x approaches infinity and as x approaches negative infinity. Based on that, it has to be option 1. Everybody okay? I know you guys went for option 1 right away, but I worry that some people weren't actually thinking about option 4 as a candidate. So this is for sure F prime. Now that we know F prime, where's F double prime? I see 2, I see 2, I see 2. Okay, let's see. If I look at the graph of F prime, easy things I like to look at. I look for horizontal tangent lines. F prime has 2 horizontal tangent lines. So what do we know? Right, that means, so horizontal tangent lines means F double prime has 2 roots. So doesn't that have to be F double prime?
Yeah.
Okay, so that one bit of evidence is probably enough. Now the tough part. Which one's the antiderivative? Which one's it? Is it option 3? Is it option 4? Show me your fingers. Is it option 3? Is it option 4? Only one person? 2 people, and now they disagree. Aaron, why are you going for option 4? What do you see about the graph of F that makes you think option 4?
Right. Yeah. Oh, because this is. I was like, because this is increasing. F of x is increasing.
F of x is
And the
increasing.
antiderivative has to be positive at that same place, right?
Hold on a second. What I heard you just say as your argument is that F is increasing. Now, is F increasing? Yes. What I heard you say is F double prime has to be positive. If F is increasing, there is something that has to be positive.
Oh,
But it's not big
F.
F.
Oh, that's it.
You're going down the chain. We need to go up the chain.
That's what it was.
Polymon, help me out.
The antiderivative speeds concave up.
That's what I wanted to hear. F is increasing. Now let's be specific. On the interval negative infinity to 0 is where F is increasing, which tells me big F is, little f is increasing, big F is concave up on the same interval. If I needed more, F is decreasing on 0 to infinity, so big F is concave down on 0 to infinity. Okay, and that was exactly why I picked this guy here. What do we say? This one?
Oh,
I was like,
I was like, wait.
Yeah, option 3. The other thing that you could have said, little f is positive, so big F has to be increasing the whole time. Everybody understand how this works? One more push. Like perfect timing. All right, flip the page one last time. Here we go. Careful, careful. I hear all things. All right. Now you're gonna play the game at like the ninja level.
There's no game.
Oh, it's a game. It's a game. Watching you all suffer. It's a great game. All right.
No, it's over.
On the far left, you have the graph of little f. One of these is f prime, one's f double prime, one's the antiderivative, one is a waste of space. All the way down. There are some deep connections if you really are going deep with the thoughts. There are some things you're going to start noticing that I won't tell you.
Oh, crap.
No, not oh crap.
My God.
There you go, that's better.
Oh, feces, that's what this
That's gonna be great. There you go.
Or like at least in Spanish or something, okay?
No,
People,
I don't know better words. That would it
be careful because I know those.
Yeah, that's why I was like,
I thought it was.
I'm gonna get a Spanish to marry. I'm gonna get a Domenico. These are related.
Yeah, these
This one is,
This was the prime, this is the prime.
Because it's clear where it's.
this has to be a prime.
That's what he said.
Matchmaking.
This one's F.
Why, man?
All right, the one with the potty mouth sitting on the left is Celeste.
I thought you already introduced this like
Yeah.
3 days ago.
Myra's wearing green, Polymon is in blue, and Aaron's the good-looking guy on the right.
There we go.
Where?
Where's Aaron? Where's Aaron, man?
So now we just have to find the antiderivative, or should we explain the other two?
No, just find the antiderivative.
Okay. So since this one's decreasing, then it's gonna be
Okay, wait,
concave
F
down,
is
concave down
decreasing.
to -2.
Negative
This is
infinity.
2.
That's the antiderivative.
Yeah.
Because
One?
yeah, because
Since this one's decreasing, it has to be
yeah, it's
concave
This is
down.
decreasing, this has to.
concave down.
Right, and then. Okay, and then.
Yeah, this one is related.
Yeah, this and it's you know it switches because when it's positive,
And then
over here it switches at.
Option 4 is the extra one. F.
Yeah, because you're not even on page. You're not even.
Option 2 is F prime, right?
I'm not.
No, F more.
Ah, crap.
You did that double.
Wait, how did you guys try it?
Because you just put F, you didn't put prime.
Row 1, what are the things that we know?
You just put that was F, when this is F.
Sorry, what?
You put F right here, you just left it, like this is F.
That's right. But there are
Oh, this is prime and leave at.
Yeah, you put that, you put that, this one was
Now.
F of X.
Yeah,
And I
yeah.
was like, what, that's right there.
But, okay, so option 4 is extra.
Yeah.
Option 4 is me.
F prime has to be decreasing.
Oh, I hear
Only
you saying
ever
it's not.
increasing, right? So which one?
Oh,
This one's absolute value.
Okay. Another easy one?
Option 3.
This one's F.
Now we know that F
Option 4 is F
What
prime.
about F double?
Option 4 is F prime, yeah,
Okay,
because we already
it
did
doesn't
that before.
exist.
We've done that tons of times.
It has a cusp.
That's a job.
So wait.
And then F double prime is option 2. And then option 3 is the antiderivative.
Only and
Option two
only
is
ever
prime.
positive?
Yeah, because
It can't be option 1 because at x equals 0,
as long as you maintain the point, it doesn't
x,
equal.
x is defined. X equals 0 cannot be defined anyway.
We just know that it's
I
not
mean,
this.
cannot.
Be existing.
Yeah, I know you know what I'm saying.
We just know it can't be this though. Because
It
That's why.
exists.
yeah.
So if we know that F
Okay.
prime.
This is extra because not even because it exists for me. As long as
Alright,
it
these
exists
are
at
not
x
random
equals 0,
functions, these are really good test
Okay,
writers.
so which one is the antiderivative?
Decreasing.
the antiderivative is option 2.
No.
No, 3.
3.
Well, negative-
And then option 2 is F double prime.
Decreasing.
Because you
It
go
doesn't exist. I know.
right, you go from here and you combine them on the
Yeah.
Okay, so you guys are done with row 1?
and row 2.
And row 2.
And well, let's see. All right, so little f, which one's f prime?
Option 3.
Option 3. Okay, give me some evidence.
Wait, I forgot. Oh, this is
Well, since this one's decreasing, then it's going
Right, so f is decreasing and then increasing, so f prime must be negative then positive. Love it. If f, okay, so now we've got f prime, you're frozen. Why did we pick f double prime, Myra? What?
Good job.
Just ignore the timer. Just keep going.
All right.
Okay, so f prime, what were we saying? Sorry.
F prime has a constant slope.
F prime has a constant slope, so f double prime doesn't change. It's just horizontal. Now, if we really want to go big brain, what's the degree?
2.
And the degree of the derivative? 1. And the degree of that derivative? 0.
And then
So the antiderivative has to be, if we're going up the food chain, degree of 3. so a cubic,
It has to be
hey,
different.
both cubic.
But this is the antiderivative because
Right now,
as it's decreasing the sense
the beginning
is
to
increasing.
Or you could say that because you know that the antiderivative is a cubic function and you know that f is positive, the constant is positive,
Yep.
that the ends of f of the antiderivative have to be negative then positive, negative down.
I hear you. So you're like in your head, you're like, I know it's quadratic, but the positive leading coefficient. So the antiderivative is a cubic with a positive leading coefficient. Love it. Love it, love it, love it.
That's what I think it's
Clearly,
Oh,
your polynomial skills are strong. Like, so strong. All right, so let's look at the second one for me.
F prime is the fourth option. It has a cusp point at x equals 0, so it's undefined.
Right, and if this is the graph of the absolute value.
Right. Yes.
Okay, F double one.
I think it.
Doesn't exist in zero. Now which one's the
Oh, it's the first one.
Yeah, but you need to, when I come back, I need to know why.
Because before that it does exist. There is no hole.
Oh, yeah.
Oh, it has a
It's a
saddle
saddle-
point.
Saddle point. Oh my god.
What?
I know.
Yeah.
I told you I'm just dumb.
No, I said told you. You're dumb.
Oh wait, this doesn't make sense anyway. How can it be a jump after it just?
Yeah.
It can't be two
It
jumps.
exists.
It can't be a jump, then go back, then another jump. That doesn't make sense.
Because
That doesn't even make sense.
it's the uncontinuity from left to right that is constant.
You're talking about this.
It can't. This doesn't even make sense.
Maybe.
Wow, we're stupid.
I don't understand how you calculate this.
F double prime.
I didn't try to either.
I think your contact with Okay, so now it's a picture of Mr. McCullough. He's like this, like where he's like this, like he has a displeased face on, and then her name
I'm
is
sorry if you don't
41.
know Mr. McCullough,
You know her birthday's October. Can't tell. Can't tell. Oh, it's on camera. So never.
but they wrote
They should not.
You would have to have it.
Nice.
Me as a
All right, friends over here, where are we?
we figured it out.
Okay, so tell me about row 2. Why is this the antiderivative? Why can't that be the antiderivative?
Saddle point. Up until the point F double prime is continuous. Or at least, like, yeah, it's continuous, and you had a saddle point of x equals 0, which is right here, where it is, and then it keeps going.
Okay. Another argument is over here.
Yeah.
For, I mean, row 2, number 3. What's the derivative at 0? Don't fall for it.
There is none.
you can't
Oh,
limits from the left.
It's not just that the limits from the left
That's
and the right are, I mean,
constant.
that's a reason. This function's not continuous,
that's
right?
the big thing.
This guy's not continuous. And the derivative is
I was
continuous.
thinking
So
that
the
was
anti has to
too
be
good.
continuous.
You need the antiderivative not just to be continuous, but differential. Right? So it has to be continuous, no vertical tangent lines, no cusp points, which is why this guy is differentiable. The derivative exists and is continuous. This guy here meets all the criteria, like, oh, we're increasing, the derivative is positive, we're increasing, derivative is positive, but I'm not continuous at x equals 0, so the derivative cannot exist. Good, keep going.
No, we should not be doing this one.
Wait, no, you just
So this one's DC, it means it's going to be
define.
Make
sure that
you watched the video, right?
You make sure that
Yeah,
f
that's
is continuous
anti. That's
and the limit
concave.
exists, and then
No, this is concave down.
you check that the
And either way, you would
derivative.
keep looking at those certain
Okay,
things.
throw it in.
So this concave's down, and it concave's up.
Okay,
right
row
here.
3, what do we know for sure?
F prime is the left.
I'll
prime
find
is the absolute last one, I agree.
And then F double prime is
You
the
can
first
find
one.
the
F double prime is the
Antiderivative
first one, I agree.
I think.
Outside.
The antiderivative
The
is
second option.
second.
no.
Do the second or the
I was gonna
third.
say we can all just.
It's the fourth.
find it.
Because you know there has to be a root
Curious, anybody know
at
what
x
the
equals
equation
0.
of the
Oh
first
wait, no, I
one
forgot. This has to be negative. I was thinking that.
You're right.
And then
This has to be negative
from
anyway.
negative pi over 2 to 0, it's increasing. So the derivative has to be positive.
You don't even have to look at that though. You can just see where it's decreasing in the constant number.
and the antiderivative?
Let's change what I
You said
said.
this was the antiderivative?
I think. No.
Option 2 is.
No, I don't know.
I think this.
No.
What?
F prime derivative.
Okay.
Derivative
I'll let you
problem.
guys
Yeah.
keep
Sounds legit.
Alright.
Wait, what were you trying to? Wait, what were you saying was the
Not, I thought
derivative?
you said this is the antiderivative.
Is this cool?
What were you saying?
Okay, you guys are on row 3?
Yes.
Okay, so if f of x is the one on the far left, which one's f prime?
I think well, f prime is.
I think it's
I don't know if this is sign because.
I wasn't talking. I was talking about the antiderivative.
I say
Oh, I was talking.
F prime,
Yeah,
F prime.
and then
Outside
goes
of
over.
product.
No, I said this is the antiderivative.
Okay. Well, that's
F prime is option 4.
Yes.
In row 3, f prime is option 4.
Yes.
F double prime?
Double prime would be. Yeah, I think that's option one.
F double
Just
prime
keep
is
finding
option
it.
4.
Because you're changing. Yeah. No, it's right. Yeah, because then you're going to this. Because yeah.
Yeah, because let's do that.
Right, look at where we're increasing. If f is increasing, I need f prime to be positive. All those
This is the
relationships.
antiderivative.
Which one's the antiderivative?
Option two.
Option 2.
Because it's concaving down and it's also positive right here, and it's also changing.
Yep. Alright, so really quick, so anybody know the equation
Nope.
for f in row 3? Is cosine. Cosine.
I'm trying to be sure.
Anybody know the equation for the derivative graph?
Oh,
sine.
Nope. Negative sine of x. Anybody know the equation for the second derivative?
The second derivative?
The second derivative?
Negative cosine.
It's negative of cosine of x. You're not starting in a max, you're starting in a min. Anybody know the equation for the antiderivative?
Isn't that something?
Sine.
That's sine of x. All right, friends, nice job
It's actually
today.
not bad.
Tonight's homework
It just
is...
looks
Hold
overall.
on. Tonight's homework has nothing to do with the antiderivative. Tonight's homework is the quiz. This is the lesson that would normally come after the quiz. All right, I'll see you guys later. Have a great day.
Do have homework for tonight.
Somebody loves you. It's just not me.
We're still recording.
Yeah.